Hello everyone, my name is Akash and I'm here with my classmate Shreya to do the presentation on the assignment 5 of the project design patterns for fall 2025. This project is basically regarding it's basically a Java Swing application that mimics the ATM machine and it uses the state design pattern. Yeah, so how you can download the submitted project is you have to go to the submissions and you will find a zip file submitted by us. So you download it and extract it. So after extraction, you will get this folder inside, and inside this folder there will be the Java files. So yeah, there are 5 Java files here. Okay, so basically what this project is, as I mentioned, it's a Java Swing application which mimics the automated tailor machine, that is ATM, and it uses the design state design pattern. So our main focus will be to add some robustness in this project by adding the error checking in the cache inventory management. So after extraction, your project structure will look like this. There will be a folder, there will be 5 files. And yeah, basically this ATM GUI file, this sets up a visual interface and handles all the buttons and keypad input events, which triggers the state actions. Then there is the display panel.java. It manages the visual output. We modified this file to include new methods for displaying some specific errors and cache limit warnings. And then there's a third file, state.java. So it defines all the transaction states such as init, deposit, and a new specialized withdrawal states. So all the business logic like dispensing cash or checking limits that resides in this file. So we'll quickly go through the changes made in this project. So yeah, first we added the pre-withdrawal limit check. We added the static field, which is here. Uh, yeah, we added the withdrawal limit in the state.java, this file, and this init.button b. Init. Okay, so we have the init.button b. So this method now calls the new static helper, which is choose pre-withdraw. And then this choose pre-withdraw, it first checks the inventory count of the num20s. And if the count is low, it dynamically lowers the withdrawal limit. And then if the cache is like very low, it transitions into a new no cache message state. So it immediately blocks the transaction. So further changes will be explained by Shreya.
Okay. The other changes were like we did a withdrawal error handling. The error handlings were also done in the withdrawal section. So in the withdrawing state, there is a when we press E button. Um, in the button when you press the button E now when it triggers two checks. It triggers to two checks before dispensing cash. So first is the insufficient fund. So if the amount exceeds the account balance, it cancels and uses the new it uses the show withdraw account error, and then transitions to the withdrawal error. And when the second case is when it exceeds the ATM limit. So if it exceeds the ATM limit, it displays a different error and it transitions to withdrawal error. The withdrawal error state only responds to button C, which is when we click the OK button, that it resets the machines again to back to the initial state. Then there's another changes we made that was uh, 20s onlys mode. So in the 20s only mode, here if helper function, it is a function which is can only offer 20s. So it returns true when the ATM machine is sufficient, when the ATM machine is it has an insufficient balance of $10 or $1 bills for changes. So the flow forces the user into the withdraw 20 states. So in the execution state, in the withdrawing 20s, we perform an explicit T1 check. So if the account is not a multiple of 20, that is, we have given the function as temp divided by 20, which is not equal to 0, then it displays a warning and it transitions back to the withdraw 20 warning. So it clears the input to force a correction. Then the last one is the dispensing and inventory changes. So upon successful withdrawal, when the dispense cash amount it executes, this logic is given to the priority. This time it prioritizes the largest bills. Like it maximizes $20, then $10, and then finally $1 for the remainder. So this method then decrements the static counter for num20s, num10s, and num1s. So simulating the emptying the vault and affecting the future transactions.
Yeah.
So
Uh,
now
so
output.
yeah, how can you execute this project is basically you write Java C space assignment 5 slash start.java. So this will basically compile all the files inside this folder. And you, as you can see, the class files have appeared here. And you have to execute the ATM GUI here. So assignment yeah, you have to write this command here. Once you write it, this GUI will be generated and the test cases will start running in the backend. So yeah, the test cases have already executed and the GUI has appeared. I'll close it temporarily. Yeah, after the successful execution, you can see the test run files have appeared here. So you can open these files and compare it with the provided outputs, and they're matching in our case. So yeah, that's how you run this project. So yeah, that's it. If you have any questions, let me know.
Thank you.
Thank you.